All right, I've skipped a couple um, of slides, so they're not extremely important. It's just to get you thinking, but you can look at them and answer the questions in your head um, without me having to read it to you. So let's talk about the secondary air pollutants. First off is smog. Smog is a result of several different primary pollutants, and it's just this thick fog-like smoke that hangs in the air. And there's actually two types of smog that we'll talk about. There's industrial smog, which is more gray in color, and then there is photochemical smog, which is like reddish brown in color. But all the pollutants that are released from vehicles and factories and different manufacturing processes, especially in cities that have are prone to temperature inversion. Some that sit in a bowl between mountains, or a city like Los Angeles that's bordered on one side by an ocean with a wind current coming in, and on the other side by mountains that won't let that wind go anywhere. So temperature inversions can happen and trap all this stuff down in there and have no way for it to get out. So you've probably seen pictures like this on the news of smog. Places like Mexico City have a really, really bad problem, and Los Angeles have a particularly bad smog problem. Here's just a kind of a very simple diagram of the causes of smog, um, which include things like nitrogen dioxide or NOx gases, volatile organic compounds, um, and ultraviolet light and heat, kind of combine together to make this photochemical smog, and we'll talk more about it when we get to the chemical reaction. All right, so we talked about the industrial smog and the photochemical smog on the left. Here is the industrial smog that's gray. It's a result of sulfuric acid. All right, so sulfuric acid is not a primary pollutant, but it is a secondary pollutant. So when we talk about acid rain, we'll talk about how SO2, sulfur dioxide, combines with water to create sulfuric acid. And that hydrogen sulfide, I keep saying hydrogen, I guess it is, but the sulfuric acid is a component of acid rain. And what does not fall out in acid rain will combine with this ammonia in the atmosphere to create ammonium sulfate. And ammonium sulfate is the gray colored, smoggy smoke that hangs out over cities that have a lot of industrial outputs of SO2. The other type of smog is photochemical smog. This is where volatile organic compounds, which are primary air pollutants, nitrogen oxides, which are also primary air pollutants, combine with heat and sunlight to form ozone. That's what O3 is. Different oxidants and peroxyacyl nitrates, peroxyacyl nitrates, which are irritants, upper respiratory irritants, and the reason that it's reddish brown is because the NOx gases are that color. Ground level ozone. When we talk about ozone, typically ozone is a good thing, right? Because ozone protects us from ultraviolet light in the stratosphere. And as long as it's in the stratosphere, it's fine. But when it's breathed in by humans, it's poisonous. Ozone is created by chemical reactions with NOx and VOCs, just like you saw back here. It creates ozone. VOCs here plus nitrogen oxides can yield ozone. And when that happens on the ground level, it's bad because ozone is poisonous. And so here's just a little simple figure of where the good ozone layer is right here, up in the stratosphere. But down here on Earth, where smog is formed and ozone is formed, it's not so good for us. Ground level ozone formation is this chemical formula right here. Nitrogen dioxide plus sunlight yields nitrogen oxide plus an oxygen, and that oxygen combines with another oxygen molecule in the atmosphere to create O3. Acid rain, the third type of secondary pollutant. We consider it to be acid rain when the pH is below 5. Normal rain has a pH of around 6. Anything greater than 5.7 is considered normal. This also, depends on where you live too. So here's the pH scale, right, where 7 is neutral and 0 is the most acidic and 14 is the most basic. I know you know this well, but I'm going to point out that the pH is a logarithmic scale. So that means that for every jump from 5 to 6, it's 10 times. So something of a pH of 6 is 10 times more acidic than water. Something with a pH of 5 is 100 times more acidic. 4 is 1,000, 3 is 10,000. So an apple is 10,000 times more acidic than water. So it is logarithmic. And then acidic over here and basic on the right. Acid rain is formed 3 ways. Carbon dioxide, which is formed by the release of carbon monoxide, which is a primary pollutant, combines with water to form carbonic acid. This was when you blew the straw in the lab and created acidic water from the carbon dioxide from your breath. That's why rainwater tends to be on the acidic side rather than neutral. Naturally occurring carbon dioxide. Nitrogen dioxide combines with water to form nitric acid. Nitrogen dioxide is released by the burning of fossil fuels. It's a primary air pollutant. That's one way to form it, human-formed, anthropogenic acid rain formation. The other way is to burn coal and release sulfur dioxide, which will end up making sulfuric acid. The effects of acid rain, wide-ranging. The deposition of salts is bad. It can ruin man-made structures. We saw this in the lab. But I think the main one that is kind of looked over a lot, but it's one of the worst, is it will put aluminum, naturally occurring aluminum, in the ground in solution. And when that happens, the solution of aluminum will run off into the rivers and the lakes. And when the fish swim, the aluminum smothers them and the fish will die. And also, it will be uptaken by the roots of plants and trees, and aluminum is poisonous to plants and trees in big quantities. So those are pretty outstandingly bad effects of acid rain.